Hello, everyone. So today we're going to be starting with our first lesson for the year. It is called Chapter 1.1, Rational Numbers. Our essential question is how can you use integers to represent the velocity and the speed of an object? And we're going to start with this we call Freyer model. And our question on the left-hand side is what is absolute value? So absolute value, right? Here's the definition. The definition is the distance of a number from 0 on a number line. Facts and characteristics, we use the absolute value to add numbers with the same sign. Add absolute value and keep the same sign. And the answer to an absolute value problem is always, or our absolute value is always positive or 0. So let's take a look at an example. So the absolute value of a negative 4 is equal to 4, and the absolute value of a positive 4 is also equal to 4. Now, let's take a look. Why? Well, the definition of absolute value is how far, right, a number is from 0. So if I'm trying to find the absolute value of a negative 4, I'm going to start at negative 4, and I'm going to find out how far away it is from 0. So I'm going to count 1, 2, 3, and 4. Right? It's 4 spaces, 4 units away from 0, so my answer is 4. Same with the positive 4. Right? A positive 4 is right here on my number line. I'm going to see how far away it is from 0. 1, 2, 3, and 4. So the answer is 4. Essentially, you could say that the absolute value always turns a number positive, or if it's already positive, then it just stays positive. Not an example, right? Well, the absolute value of 7 is not going to be a negative 7 because my answer is not positive. And we just mentioned that my answer should always be a positive number. And 2 is not equal to negative 2. Well, this is a non-example because it does not have these lines right here around any of these numbers, which would represent the absolute value. Okay, let's move on to the next slide. All right, so here are a couple of examples. To find the absolute value of 2. Okay, so here we went ahead and we drew a number line. I'm going to graph 2 on my number line, and I'm going to find out how far away it is from 0. Well, it is 1, 2. It's 2 spots, so the distance between 2 and 0 is 2. So the absolute value of 2 is 2. Remember, we said our answer is always going to be positive. Let's do the same for this one. Find the absolute value of negative 3. I want to find out how far away negative 3 is from 0. So let's go ahead and count 1, 2, and 3. We graph negative 3 on a number line. I just found out that it's 3 spots away from 0. So your answer is 3. Remember, an absolute value always is going to have a positive answer. So the absolute value of a negative 3 is 3 because it is 3 spaces away from 0. Again, we're going to count them. 1, 2, and 3. Right there. Okay, so now let's go ahead and let's try some of these practice problems here. So what I'm going to do is I'm going to open up a folder, and I'm going to go ahead and write these problems down so we run them. Okay, so I'm going to go ahead for a second and share I'm going to stop presenting this screen to you all so I can present. All right, so you can see my whole screen as opposed to just that window. And we're going to go over those problems. Okay, so here are our practice problems that we're going to go over. So we're going to find the absolute value of 7. So I could draw a number line for all of these. Right? It will take a bit longer, but I can do it. Or, right, we can just figure out how far is 7, right, away from 0. Or you can think of, remember, the absolute value will always turn a number positive. And if it is already positive, then it stays positive. Therefore, the absolute value of a positive 7 is just a positive 7. Number 2, I have a negative, right? Well, -1 is one space away from 0, or is a negative. So this absolute value right here is going to turn this negative into a positive. So the absolute value of a -1 is just a 1. Doing the same thing, the absolute value of -5 is just 5. Absolute value of a positive 14 is just 14. So we notice that all our answers are negative, or sorry, all our answers are positive. Number 1 and 4 were positive, so they stayed that way. And number 2 and 3 were negative, so now they turned into a positive. For 5 through 8, it says copy and complete this statement using less than, greater than, or equal to. Well, before we can do that, we're going to use the absolute value to figure out what these numbers will be. So, for example, the absolute value of a -2, right, we know is going to be a 2, and 2 is going to be greater than -1. So 2 is greater than -1 because a positive number will always be greater than a negative number. Let's see, simultaneously right here, right, the absolute value of 6 will be a 6, and a positive number will always be greater than a negative number. So the inequality is going to look like this. Absolute value of 10, and it's positive, so it's going to stay positive. Well, 11 is actually greater than 10, so it will go this way. And 9, the absolute value of a -9 is a positive 9. And 9 is actually equal to 9. So once we figured out the absolute value of these, then we can go ahead and complete, right, this statement using the inequalities. But we had to figure out the absolute values first. So this was this way. 10 was less than 11. 2 was greater than, right, -1, and so on. Okay, that's it for the practice problems. And I believe that concludes our lesson. So now we are going to try the assigned problems for this first assignment on Big Ideas Math. And we'll see how we do. If you have any questions, feel free to ask me. You can also rewatch this video at your own pace if it helps you better understand the topic by pausing the video, paying attention to what I did, and playing it at your own pace. I'm going to go ahead and stop presenting, and I hope everyone has a great rest of your day. Take care.